Hi class, today's video is going to be all about triangles. There's actually going to be two parts. The first part will be about classifying them and using their angle measures, and the second video will be more focused on congruent triangles. Let's go ahead and talk about the ways we can classify triangles. There are basically two methods. We can classify triangles by their angles or by their sides, and hopefully these vocab words will seem pretty familiar to you. When we classify a triangle by its angles, we can use the four words listed: acute, obtuse, right, or equiangular. And just as a reminder for these, an acute triangle would be when all angles are less than 90. When it's an obtuse triangle, that would mean that you have one angle greater than 90. So I'll put that there. So one angle that's greater than 90. And then a right triangle would be one angle that equals 90 degrees. And then equiangular, which may not be as familiar, this means that all the angles are equal. Okay? And in that case, it's going to be that they're all 60 degrees. For sides, same concept, but we have three vocab words: scalene, isosceles, and equilateral. Scalene, if you remember, means that all the sides are different lengths. Isosceles means two or more sides are congruent. And then equilateral just means that all the sides are congruent. And if a triangle is equiangular, then it will automatically be equilateral. So that's kind of a cool little connection between those two. Let's look at these examples where I just have a picture of triangles. If I told you this was 110 degrees, and that's all I gave you, right away we would be able to identify this angle by its obtuse angle, so we would know that this is called an obtuse triangle. And the reason we know it's obtuse is because there is one angle greater than 90. Even though the other angles would have to be less than 90, automatically we know it's obtuse from the one angle. I could also give you some side lengths. For example, maybe this is 12, this is 6, and this is 4. And if I asked you to classify it by its sides, then we would know that because they're all different, this would be a scalene triangle. So you can classify triangles by both angles and sides depending on the information that's given. Same idea with this triangle here. If I look at this example, maybe this was 50 degrees, this was 80 degrees, and then we could calculate this last measure. We would know, because all three angles would be acute, this would be an acute triangle, and then we'd be done. So if you have any questions about how to classify by the angles or sides, make sure you let me know, but hopefully those seem relatively familiar. Let's use these concepts to look at more complex pictures. So in this example, it says point M is the midpoint of JL, and we want to classify triangle JKM based on the measurements. So if we know that M is the midpoint, that means that my side JL is getting split in half. So if the whole thing was 1.5, then each side of that, JM and ML, would be 0.75. So I'll go ahead and write that in there. And then the other thing that's really important here is that they mark two sides congruent with those little dashes, and we talked about that back in Unit 1. Those dashes mean that those side lengths are the same. So what we can tell from this is that if I know 0.75 is ML, then that means MK is also 0.75. And now we can go ahead and look at our triangle JKM. So here's JKM. And if we look at its sides, we notice all three sides are 3/4, which means that this would have to be an equilateral triangle. And that's it. So just know that sometimes you're going to have to fill in side lengths or measures in order to be able to classify it, and normally it's going to be just some quick calculations, and that's all you're going to have to do. Now in this example, you're actually going to find the measures of the sides based on the information here. So it says that it's an isosceles triangle, and that we have on this picture marked that this side and this side are the same. So we know, because they have the dashes, that 12 minus D and 4D minus 13 are going to have to be equal to each other. So that would be where I would go ahead and start off this equation, and I would solve for D. So I'm going to add D over to the other side, and I get 12 equals 5D minus 13, then add 13 over, we get 25 equals 5d, so d is equal to 5. But remember, it said find the measures of the sides. That's important. So we need to go back and plug d into each side length, and then we would be done calculating. So here, 5 plus 6, or that would get you 11, so that side's 11. 12 minus 5 is going to get you 7. And then 4 times 5 is 20. 20 minus 13 is 7. So we have two side lengths that are 7 and one that is 11. And notice it said it was isosceles, so we have two equal sides, and that's perfect. If it ever said it was isosceles and you get three different measures, or if you get negative measures for your side lengths, then that's a big red flag that maybe you've calculated something wrong or that your equation needs to be adjusted. The next theorem that we're going to be talking about is the triangle sum theorem, and hopefully this will seem familiar. What this theorem says is that the total of all the angle measures in a triangle should add up to 180 degrees. And this is very, very useful when you are trying to calculate side or missing measures. For example, in this picture, we have three different angle measures given, and they want us to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. So we just have to know our different measurements and do some addition and subtraction to find the three missing ones. So let's go ahead and start with angle 2 here. And the reason I'm starting with angle 2 is because in this triangle that I'm outlining, I already know two of the three angle measures, and according to my triangle sum theorem, the three angles together have to add up to 180 degrees. So what I would do is take 57 plus 71 plus the measure of angle 2 and add them up to equal 180. And now I could go ahead and start solving. 57 plus 71 is 128. And then I could subtract 180 minus 128, and that would give me 52 degrees. So the measure of angle 2 is 52 degrees. The next thing we could do is solve for angle 1. So angle 1, if you notice, is right next to angle 57. They are linear, and that's an old vocab word. And remember, when we know things are linear, that means they're supplementary. So I know that the measure of angle 1 plus 57 would also have to add up to 180 degrees. So if I take 180 minus 57, we would get that angle 1 is 123 degrees. And then lastly, we could solve for angle 3. So now that I know this is 123 degrees, I have two of the three angles in the triangle. So I would say that angle 3 plus 28 plus 123 would equal 180 degrees as well. So you could add and subtract that over, and that would get you your final measurement. So it's just a bunch of addition and subtraction. You just have to know which angles to add together. If you have any questions on that example, please let me know.